Hello everyone, welcome back to Math with Allison. Today we're continuing our integration series, so we're going to be talking about the mean value theorem. So let's go ahead and dive into it. So in order to learn about the mean value theorem, we're going to have to build off the average value theorem. So if we remember, the average value is equal to 1 over b minus a multiplied by the integral from a to b of f of x dx. If you wonder how we get that, you can make sure to check out my previous video. Otherwise, let's go ahead and do this thing. So let's take this image right here. We have our function f of x on the interval a to b. And let's go ahead and say that we have an average value randomly here. I'm just going to pretend that that is our average value. So f bar. Because we have a continuous function, then our average value must hit the function at some point. So notice right here, this is where we hit the function, and we can find a corresponding c value. And so this point right here is going to be f of c, right? That's going to be the height of the function. So what this means is that we can have some point f of c which is equal to the average value. But we can go ahead and fill in what the average value is equal to. And this is 1 over b minus a times the integral of a to b of our function in terms of x. So now what I'm going to go ahead and do is I'm just going to go ahead and multiply this b minus a over to the other side. So let's go ahead and talk about what this means. So here we have a height of f of c, which we already found indicated by this function point. But now we are multiplying this by b minus a, which is going to be this entire length. It's going to be the interval between a and b. So what we're doing right here is we are finding the area of this whole rectangle. So this area of the rectangle is represented by b minus a multiplied by f of c. So now let's talk about what this is equal to. So here we have this is equal to the integral of a to b of f of x dx, which this represents the area between the curve and the x-axis, right? So it's going to represent this whole area. So what this is saying is that we can actually find the area under the curve by using this rectangle right here. So let's go ahead and talk about what this officially means. Here we have the theorem, let f be continuous on the interval a to b. Then there exists a point c in the interval a to b such that f of c is equal to the average value, or 1 over b minus a times the integral a to b f of x dx. So let's go ahead and see this in action. Here we want to find all points at which the given function equals its average value on a given interval. So we're going to apply the mean value theorem. Our first step is to actually find the average value, right? So I'll go ahead and set that up. I plugged it into our formula, and here we can start simplifying. So we get 1/4 times, and let's go ahead and find the antiderivative. When we have a constant, we just tag on that x. And then here we have minus 2x squared divided by 2. I add 1 to the exponent, divide by that new exponent. If you want, you could immediately divide these out, and this is actually just equal to x squared. And this is being evaluated between 0 and 4. So let's go ahead and plug in those values. I'm going to go ahead and do upper minus lower. So here we can see this whole term goes to 0, so we kind of get to ignore it. And I'm going to go ahead and math this out. So 8 times 4 is equal to 32 minus 16. So here we get 1/4 times a value of 16, which is equal to 4. So here we found the average value. We're not quite done yet because we haven't applied the mean value theorem. This is saying that we can take our function. So here we have f of x equals 8 minus 2x. And there must be some x value where this equals the average value. So I'm going to go ahead and take that 8 minus 2x and set it equal to our average value, which is 4. And now I'm just going to go ahead and solve for x. So let's go ahead and subtract 8 from both sides. I get negative 2x equals negative 4. Divide both sides by negative 2. I get x is equal to 2. And this right here is the value that satisfies the mean value theorem. Let's go ahead and talk about what this means graphically. So here we have the graph of our function. And we got the average value of the function on this interval was equal to 4, which is that line I just filled in. So because this is a continuous function, the average value must hit the function at some point. And we were able to solve for that point, and we found that that was equal to 2. So this is what that means graphically. Another visual we can think about is that we just found that this area right here, everything beneath the curve, so this would be the integral of 0 to 4 of our function, is actually equal to this area where we took our average value and we multiply it by the length of the interval. Now let's go ahead and try another one. So here we have our function f of x and we have our interval 0 to 2. Again, our first step is to go ahead and find the average value. So let's go ahead and simplify this. So we get 1/2, and let's take the antiderivative. Antiderivative of e to the x is just e to the x. and we're evaluating this between 0 and 2. So here we can go ahead and plug these in. So we get e squared minus e to the power of 0. And we can go ahead and simplify that one more time if we wanted. So we get e squared minus 1. So there's not much else to simplify here unless you want to plug it into a calculator. But our next step is to take our function and set that equal to the average value. We want to see where it hits the function. So here we get e to the x is equal to 1/2 e squared minus 1. So here, in order to get x all by itself, I'm going to go ahead and take the natural log of both sides. That way I can bring the exponent down, so I get x times the natural log of e is equal to the natural log of 1/2 times e squared minus 1. Here, natural log of e is just equal to 1, so that goes away, and we get x is equal to natural log of 1/2 times e squared minus 1. You could simplify this out a bit more using natural log rules. I don't know if you'd have to, but I'll just do it just in case. Whenever we have multiplication going on in natural logs and logs, we can just simplify that by making them add. And here we get our final solution. So this is where the average value hits the function. Let's go ahead and try a trig one. So here we have f of x equals pi over 4 times sine of x on the interval 0 to pi. Again, in order to satisfy the mean value theorem, we're going to go ahead and find the average value first. So here we have 1 over pi times the interval 0 to pi of pi over 4 times sine of x in terms of x. So if you wanted, you could simplify this first. Notice that the pi's cancel out and we're just left with a 4 in the denominator. Here we can rewrite that as 1/4. We can bring that scalar out to the outside. And now we're just integrating sine of x in terms of x. So if that's a bit simpler for you, you can totally do that. Here we get 1/4, and we'll take the antiderivative, so that becomes negative cosine of x. And then we're integrating this between 0 and pi. So I'm going to go ahead and plug in upper minus lower. So here we get 1/4 is just hanging out. Negative cosine of pi minus a negative becomes a positive. So we're going to add cosine of 0. So let's go ahead and figure out what these are. Cosine of pi is equal to -1. So we get negative 1. Plus cosine of 0, which is equal to 1. And so this is going to give us 1/4 times 2, which is just equal to 1/2. And here is our average value. It feels easy to stop here, but of course we have to do the last step where we're finding where the average value hits the function. So let's go ahead and find that x value. We're going to take our function pi over 4 times sine of x, and we're going to set it equal to our average value. So here I'm going to go ahead and multiply both sides by 4 over pi. That way I get these cancel out. Here, one of these can cancel out, and we get sine of x is equal to 2 over pi. In order to get x all by itself, I'm going to go ahead and take inverse sine of both sides. This way, the inverse sines cancel out, and we're left with x is equal to the inverse sine of 2 over pi. I don't know what that's equal to. You can use a calculator, but I'm going to go ahead and leave it at that. So that's all I have for us in the video today. If you enjoyed it, I have many more like it, so make sure to check out my playlists. They're linked down below. Otherwise, please give this video a thumbs up and comment other problems or topics you'd like to see done. Thanks for watching.